The SIG and working group update is converters essentially, and it's covered by Chen from IBM and Guenther from Microsoft. Chen and Guenther, do you want to share?
Okay, I can share. 1 second.
Yeah, go ahead, Guenther.
Okay, can you see?
Yes.
Yes.
Yeah. Okay. Hello, everybody. I'm Guenther from Microsoft, and I have some front-end converter updates. I start with the easy ones first. So PyTorch Exporter is supporting PyTorch 1.10 and up to offset 14. And the team added support for more ops and enhanced the shape inference. And the enhanced shape inference allows more models to be converted. And then for sklearn, it's supporting offset 15 and sklearn 1.0. And the team tested more models, like 125 models that are now converting. And we did performance measurements, and for batch sizes up to 10,000, ONNX runtime is quite a bit faster than sklearn. So those are the easy ones. Now comes the complicated one, TensorFlow to ONNX. So internally, we had limited resources, and so we stopped active development on Keras to ONNX. And one reason is we are short on resources. The other reason is it took us much more effort to maintain Keras to ONNX with the changes in TensorFlow on the upper level. And after TensorFlow 2.3, that effort became too big. So we decided to support Keras models with TF to ONNX instead of Keras to ONNX, and just stopped active development. We moved all unit tests from Keras to ONNX under TF to ONNX. We tested like a couple of 100 Keras models, so we are kind of sure we are not breaking much. So we expect very little friction to switch. The API, the Python API for TF to ONNX, we improved it, and it looks very similar to the one that Keras to ONNX is using. So we hope that is not a problem. But there's one gotcha. So the big difference between Keras to ONNX and TensorFlow to ONNX is that Keras to ONNX picks up the model on a very high level, on the Keras level. So if you have, for example, an LSTM in Keras, Keras to ONNX will see, oh, this is a LSTM, so it's very easy to map it to the ONNX LSTM. For TF to ONNX, it's very different. We asked TensorFlow to give us a graph for this Keras model, and TensorFlow doesn't really have an LSTM operation, so we see just control flow at a very low level, and we have no idea if it is a LSTM or not. So our code that need to match part of the graph and say, oh, actually this is the LSTM, and you can replace it with the ONNX LSTM. That code is very complicated, and we had issues with this code. We hope we fixed most of them. It definitely improved, but there might be still some issue that we are not finding a TensorFlow LSTM and convert it correctly to a ONNX LSTM. And the result of this is basically the model will still work, but it's using control flow to implement the LSTM, just like TensorFlow would do. And we could do, you take a performance hit because we are not using the ONNX LSTM. So if you run into this, please file an issue and we will try to fix it. Let me see. And then TensorFlow to ONNX supports the latest version of TensorFlow, which is 2.6. and we support offset 15 in the master. We have not released this because we are waiting for a fix in the ONNX package. The way TensorFlow to ONNX calls the shape inference creates a problem in the ONNX package, and it's fixed, but it's not released yet. So we are waiting for this before we release offset 15. And then we added a new feature. So we added support for TensorFlow.js models. So you can just take a TensorFlow.js model, and TF to ONNX will convert that as well. So we are now converting old style TensorFlow models, Keras models, TF Lite models, and TensorFlow.js models. And we tested pretty much with every TensorFlow.js models that we found in the TensorFlow model zoo in a TF hub. Yeah, and yeah, that's basically it. And with that, I hand it to Kevin to talk about TensorRT.
Thanks, Guenther. Hopefully everyone could hear me fine. So I'm Kevin from Nvidia, talking about the updates that we made to ONNX-TensorRT. So the major updates here is that we've released a new TensorRT version. The EA was released on 9/30, and the GA is coming soon, either end of this month or early next month. And kind of the large updates that we have here is that we've added new operator support for 7 new operators, and we've updated operator support for a few as well. Yeah, look forward to using the new TensorRT 8.2 version with more operators supported. Yeah, so that's the updates for ONNX-TensorRT. Chen can go ahead and provide the updates for the other backend converters.
Yeah, thank you, Kevin. I'm Chen from IBM. I'll talk a little bit about ONNX to TensorFlow converter and some general discussions we've had. For the converter, we made our 1.9 release in late August with offset 14 fully supported. The total coverage is standing at about 93% on the ONNX backend scoreboard. We're up to the latest TensorFlow 2.6 and added the ability to load ONNX models with external data in separate files. Moving forward, we've been working on offset, of course, and the inference graph-based training will be enhanced to be more flexible to work with subgraphs. We will also look into possible TensorFlow Lite support, since some of our users are actually just loading the converted model to run on mobile and the edge devices anyway. All right, next, please. So a couple of general discussion topics here. First, we found it's getting more and more difficult to maintain code to support all ONNX offset versions, right? Our unit tests are typically done at point in time. So it's not very easy to rerun all like old operator tests when a new version is introduced. So here are a couple of questions, right? Can we totally depend on the ONNX version converter to do the job, right? To make the model into the newest versions? If that's the case, all backend converters can focus mainly on getting the most recent spec, working with the latest backend frameworks. Yeah, the other one is, can we somehow deprecate some older versions? I believe there are still like offset 1 and 2 models in the model zoo right now. The other item is we would like to stress the importance of high quality standard backend tests, because we depend on this set of tests as the first checkpoint for the operator spec and also expected behaviors. So a robust set of tests would help not only us, the converter developers, but also for people to review PR and validate the functionalities, right? For instance, a converter developer recently found a couple of broken tests and eventually fixed them, of course. However, this could have impacted others to understand and verify the meaning of these operators. Right, so a solid test ecosystem will definitely, help the ONNX community to grow. Right, next please. Yeah, as far as the roadmap topics, of course, the most relevant are the offset conversions and some particular converter improvements for better performance. The version converter, we believe, should operate generally between offset versions rather than focusing on like individual operators or certain models. So we're very happy to see a good progress already made, right, to make this version converter as a key element of this whole ONNX ecosystem. Some others are also on our agenda to review, for instance, the meta information end-to-end pipeline in one graph, and new operators for data processing, because eventually all these will have to be converted from and to some frameworks. All right, that's it. Thank you very much.
Thank you, Guenther, Kevin, and Chen.